Oh, yeah. Woo! We're getting fancy today. Excuse me? I got a strange thing for like wearing LEDs. Boom! Check it out. Ooh. And I can adjust this with my phone too. Check it out. We're gonna go Volcano red today. Deep red. Deep. Because you can't see it on the camera otherwise. Oh, in case you're wondering what my phone is, there you have it. Everybody seems to ask. It's not really that fancy. Welcome back, my fellow duplicants, to Oxygen Not Included. Today, we are continuing the Volcano Power Design Challenge. This is episode 4. And in this episode here, we're going to simplify things down. We've learned a lot of things that work, and we've also learned things that don't work. And a lot of the comments that you guys were talking about last time was really based on things that were not necessarily working that well. We had a problem with the petroleum kind of going all over the place. I'm just going to unplug that. Yep. Okay. I think I have too many USB devices. Okay. Focusing back on what we're doing. This petroleum down here, when it was going from crude oil into petroleum, it was kind of getting all over the place. And there was a couple different theories or things that people were talking about over here. One of them being the temperature difference. It might have been cooling down at the moment that it was trying to convert. That was one problem. Maybe the speed of the game. The thing is, I stopped having problems when I had a little bit more space. I had a very restricted space, so I think it was trying to put stuff in places where it shouldn't have gone. That might be part of it, but the main idea is that this system down here of using doors to thermally separate two areas in a hot plate in order to convert crude oil into petroleum, it works, and it works well. However, I think what I'm going to do is what I probably should have done from the very, very, very beginning, but you know what? We always come back to that realization after we've created a couple monstrosities, is I'm going to zone things off here. So the first area, I'm just going to convert into natural gas. And once I have enough natural gas, then I can open it up and transfer that into another zone where I will just make steam and take a little bit of the heat off of that natural gas. That way I can preheat the things like crude oil up here, which does work. This works really good as far as bringing it up to temperature and also getting some of that energy back out of the natural gas, because obviously we have to get that natural gas down to a nice cool temperature before we can actually pump it away, because these pumps will break at 125 degrees Celsius. So we got to go from around 500 down here to 125 by the time we're out. So the system will actually work from left to right or right to left, depending on, well, we'll try to go from left to right just to see if we can make it work that way. So if we look at this in rooms, we're just going to create a couple of simple systems that will then just kind of stack into each other, and hopefully it'll be set up in such a way to where if we wanted to have a backup system in case we wanted to get into some areas and actually just kind of grab the dirt out of it, then we can do so. We don't have to worry about having automated systems, although there was one comment over here which actually was kind of crazy. It almost looks like he's got auto sweepers in oil, which I don't know how that works, because I tried putting them in liquid, at least polluted water over here, and they just flood. Although it looks like you can kind of get some up on it. You might be able to be a little bit tricky with the auto sweepers to kind of, if we want to get real fancy with it. We're not going to get fancy with it, though, right now. What I'm trying to do here is going back to the main goal, which some people may not remember, but that was to generate basically as much power, to get as much power out of this volcano as we absolutely can. So going back to what we had over here is we had a system that was doing some calculations based on what kind of energy we could potentially get out of some of these volcanoes. And right now, I think I'm harvesting nowhere near what these volcanoes can put out. Let's just see what some of these reports are. I've let it run for a little while here, not at an accelerated pace, but at a slower speed. And you can see that we're generating, just out of the natural gas generators, 4,500 kilojoules right there. And the day before that, 4,700, 5,000, so it's kind of starting to taper down. And it might be tapering down in such a way that it's actually starting to even out. But the main goal here is to try to come up with a system or a series of systems that'll allow us to get near these maximum numbers if we so wanted to, but also to maybe be a little bit more practical in that we can, you know, if we only want to siphon off 2,000 or so of these kilojoules, then we can do that without having to kind of redesign everything. All right, so let's just jump right on into it. I'm not going to go through all of the building this time. I'm just going to go ahead and go quiet for a little bit, build it, and explain what I've done, because at this point, you've seen what all of these systems are, and I'm just going to refine them at this point. Oh, but the one thing I wanted to mention that I think is going to be really, really important here was actually mentioned a couple times down there in the comment sections, and that was... this is actually the second time I've heard this one, but this is from Mark. So what Mark is talking about here in his comments is that basically keeping those natural gas generators nice and cold will actually kick out polluted water at a very cold temperature. And that was actually, somebody did the math on the last episode, is in the comment section, and that was right around 30 degrees Celsius they were talking about. So actually, if we look at the thermal overlay, what we can see over here is that as these natural gas generators are running, the polluted water over here on the left is actually quite a bit warmer than what we have over here on the right. You can see this is like 9.2 degrees Celsius and whatnot. So if we keep these natural gas generators in kind of a bath of hydrogen and then put a wheezewort inside of there, what we should see is that we can keep that nice and cold and potentially get a lot of very cold polluted water out of it, and then use that polluted water in strategic areas in order to condense like steam back into, you know, purified water, and just to kind of take the edge off of everything. So really, we're going to use that polluted water a lot. So I'm going to set this up over here as a little bit of an experiment. I'm going to isolate off one of these natural gas generators and put helium around it with a wheezewort inside of it to see what happens, because I want to get some sort of idea of just how many generators I can cool with a wheezewort. All right, so that's set up. We can see inside of here it's about 44 degrees, and then there's a couple of them inside of here. Let's see if a wheezewort can keep up with that. And yeah, I know it's not in a flower pot, but debug mode, you can do all sorts of fun stuff. Anyhow, let's move on. Big volcano, come to me. Bam. You know what? There's a big volcano right down here, just waiting to happen. Seems like a perfect place to go ahead and try to build some stuff. Boom! There we go. All right. So I've got this first little chamber here. This is going to be the transfer chamber. So all the heat down here is going to go up through these tiles, through the doors, and up into here. And there's nothing else going on inside of this chamber except for the fact that it is going to open up and let a lot of that natural gas through. I'm also going to be dripping down from a little bit higher, so that'll be useful there to kind of let things spread out. There was some comments talking about that. And one of the big improvements, which I think is already shown over here, these things used to be overheating, but as you can tell, they're in a vacuum right now. And the reason that that is working is because the pipes that are connected to that liquid shutoff valve, instead of being made of wolframite, those are actually made of abyssalite, just right next to it. The other areas are still made of like the wolframite in order to conduct the heat inside to the liquid. But so Micah Chase, we can thank them for the comment right there. Abyssalite connecting to the shutoff valve will keep that safe. Now that's because the liquid doesn't necessarily transfer the temperature inside of the liquid shutoff valve, even though it might kind of show that liquid moves through it. It doesn't actually contain any, I guess. So there's really, it just kind of separates the pipe or lets it flow through. So since we're putting something that is thermally not conductive at all right next to it, which is just some abyssalite, it doesn't affect that shutoff valve at all. So that is an easy way to keep that thing from blowing up. So that's what I'm going to do right on over here. It's also a very short run, so once we turn it off, boom, it'll be off. So we don't gotta worry about it. A little easier to control. So one of the things about this steam turbine is that it always seems to let stuff pass by it. So even if this is steam, right? Steam, gas, and I paint a bunch in there. Let me just save it real quick. You never know when this is gonna blow up in your face. Yeah, see, it's still getting out. So that's why I'm always putting like doors and stuff to kind of keep that stuff in there. Stop getting all over everything. Stop it! I mean, this is what I want to happen. I want condensation, but I don't really want it. Go away! Stop! I've got the LEDs set to Volcano Pulse now. That's the new custom profile I just decided to upload. Speaking of which, these are going to be part of my new 3D printer because, I mean, if I'm going to show it off, I better show it off with style. But check it out. I got this. So this is one of my parts that I've been building for it. And this one actually came out pretty good. Actually, I'd say the print quality isn't quite as good because I'm using really, really cheap filament for this thing at this point. But you can see it actually looks pretty dope right there. I'm using like an ironing technique right up here, and that makes for like a really, really smooth top surface right there. One thing I wanted to mention though is that if you guys are out there and you guys are like, maybe you do like 3D design art or something like that, one of the things I want to do with my 3D printer as I try to eventually get to the point where I'm going to integrate it into my channel here is I would like to do some cool prints and actually show them off on the 3D printer. So one of the things that people have asked for as I've been talking about this printer, hey, get back up here, is that I print like a duplicate or something like that. Now, I'm not a very artistic person when it comes to like 3D modeling. I do functional things like this. Like I can make this thing stretch and skew and move all over the place with like a push of a button or maybe just even a thought. I can do that like really quite well. However, it's not fancy and artistic. So if you have something like that, you might want to leave it in the comment section or actually just send it to my Twitter or something like that, because I want to be able to show that off here in the next couple of weeks. I actually have some time off that I'm going to dedicate specifically to this channel and trying to incorporate the next step for this channel, which is hopefully to become more professional on YouTube, which means full-time, people. I know, I'm just saying it right now, but that's the goal there. And part of that is I have to create things of value, and that is part of what the 3D printer is about. Don't get me wrong, there will be lots of video game playing, but there's a whole bigger discussion about what I'm trying to talk about here, and that will be talked about later. So guess what I'm saying here is if you want to model something up that's Oxygen Not Included themed right there, put it on Thingiverse or one of those other sites, you can feel free to share that with me because I want to actually create some of that stuff and kind of show it off. There you have it. If that interests you, you know where to find me. Let's take a look at what we have going on up here. These natural gas generators are not necessarily running 100% of the time. They do run often, but not all the time. This one's 40 degrees. This one's 38 degrees. So the natural gas generator over here is 45 degrees Celsius. You can see that the polluted water is 45 degrees. What do we have down here? Polluted water, that is 39 degrees because that is the temperature of the natural gas generator. So let's go ahead and deconstruct some of these other pipes so that those run a little bit more. But that looks promising thus far. So you can see how the system is working now. We have this area over here on the left where it's going to be creating a lot of natural gas. We're going to let this through, and then we can power up 1 or 2 steam turbines. And there was one last thing I wanted to do inside there. I wanted to add a mechanized airlock just to kind of restrict the flow through here and allow that to kind of slow down a little bit. Tell you what, we won't get too crazy with it. We'll just do something like that and then tile it off. Yeah, just like that. So the idea here is that we have this airlock that can open up in the case that you want to go in there and grab the dirt that might be built up inside of here, because that'll be fed by polluted water. So there will be some dirt that gets dropped inside of that room. Boom, boom, boom. There we go. Okay, so stage 2 over here is generate steam. That should drop our temperature down pretty good. Now we want to incorporate a nice radiator system that'll feed this guy up there and also heat up kind of a pool of crude oil like we have over here. And by the time it's done with that, we should be down in the range of below 200 degrees Celsius from what I'm seeing here. Maybe even a little bit more. We have a tolerance that is up to 300, well, we have a tolerance up to 400 degrees Celsius. So we can actually, you know, it doesn't, I can just have a full tank in there, but actually I can't have a complete full tank in there because the tank also needs to be stable enough not to destroy its own pumps. So I'll have to do a little bit of thermal isolation right there. But here's what I'm going to do. We're just going to create a radiator right here. And then beneath that radiator is going to be a nice tank of crude oil. Yeah. There we go. Hydrogen gas. Put a couple kilograms of that down there. And that will work as the medium for transferring the thermal energy from here to there. Inside of there would be crude oil. So one thing I'm noticing here is that each chamber is getting bigger. I don't know if that's going to cause problems or if it's actually just going to be, like it'll actually work out pretty good. Because it might take longer. The cooler that gas gets, the closer those temperatures get together, and it should take longer for the energy to transfer across. So that makes sense why I might want to make it bigger. So this should be running more than that, and this should be running more than this should be running. You get the idea. Rather than using diamond, we're going to keep using tungsten here. We want to make sure that the temperature inside of here stays relatively even. Pretty much throughout everything we're doing here, we'll want to, mix in a couple of these thermal shift plates, because that's what they're really designed to do. Oh, I want the steam to come out. Okay. And then it's going to condense into the cool polluted water. So it's coming out, and it's still 250 some degrees. We'll probably see around 200 and some degrees over here, but we want to condense that down into the last zone over here, which is just going to have clean water at the bottom. And that's also, do we throw natural gas in there too? No, here's what we do. We put the tank right in the middle. And this tank will have both, this will have clean water, and it will also have polluted water. I want to make sure it's nice and robust too, because you don't want it to explode. What am I doing? That's made of abyssite, and that's not going to work. Get out of there. Metal tiles, tungsten. Metal tiles could probably just stand up to like everything, so it doesn't really matter. So there we go. But we don't want that. I want to separate at least those two. And I suppose that door doesn't really matter, because you could just run through here if you have an exosuit on at this point. Okay, so if I have clean water, then I think I want to have this be mesh right here. You too, no puddling. And polluted water will more or less get pumped into this area over here before it reaches a temperature, and then it kind of gets moved off to this area over here. So it gets preheated to about 100 degrees Celsius, and then it'll get moved over there. So what I really need to have here is these liquid tanks need to have thermal control doors on them as well. So, not the clean water. The clean water will more or less always be hot, but the polluted water, that's the one that needs the control. Woo. So how do I do this? Clean water is coming out over here. Okay, and polluted water I want right here. And then I want to be able to pump that polluted water around so that it cools. Here's what we do. We build a condensing waterfall. Yeah, that'll be fun. So as I'm pumping polluted water into this space, I want it to go over here and then drip down and fill up this reservoir down there. Now I probably can get away with not actually doing this like this, but just doing one single tile, but I'm not going to risk it. So it should become cold enough. Maybe I want to actually not put it right there. I really want to make sure that this steam gets out of here before it ever gets cold enough. So I think in this last little area here, I'm just going to make sure that I am insulating the moving steam from the cold tiles. So then I'll also put the thermal shift plates in the background here. So this is where it should be cooling down, and we should see rain forming in this area. And then if I make this out of mesh, then you can just run right across it, and it's no big deal. So something like that. And then I can have two vents up here. One of them could be like a recirculating system in case I don't have more polluted water entering the system. And then the other one is also the drop-off from the natural gas generators. which means the last step here is to take the steam and just let it go over there. Condense water. I really want to make sure that no clean water is getting over here. So we're going to leave a door just like that. There we go. So we can come through, go into here, do your thing. Steam, condensation, water. We're going to do something with water once we have it. It's useful for oh, yeah. For the other, hopefully we're not going to use up all the polluted water. Some of that will be then converted into clean water. No, the clean water will be converted back into polluted water because we're using skimmers. Aha, that's what it was. And then, to finish things off, another thermally controlled door system with duplicate access. Nice. All right, so over here, crude oil comes into this area. Did I say I wasn't going to talk through this? Because I definitely just did. Whatever. We're going to put them on the far side of the room. Actually, we'll put them down low because the temperature will be cooler down here. This didn't work out quite as well as I would have liked it because I forgot about these things need to be able to shut off it so I don't accidentally turn this polluted water into steam. That would be bad. Or actually overheat it and also melt stuff too. You could imagine a lot of bad stuff could happen in that room. If it's going to happen anywhere, that would probably be where it's going to happen anyhow. So let me deconstruct this and move those doors down a little bit. And then we'll fire up the system and see if it works. Drop one of these natural gas farms down. There we go. Alright, so now just to plug in the rest of the automation, sensors and stuff. Alright, so hydro sensor, right down there. Won't use NOT gates and stuff, you'll be fine. Oh, buddy. So if that's below 0, you know, if it goes to above that, then it'll shut down. Nice, very simple. The Atmos sensor is also very simple. We're just going to have that up here. And all that's going to do is open these if it is above 20 kilograms. I'll use a filter gate to control this one so that I can keep the pump on for a little bit. And I can control how much time that is. Just so that it isn't like a fraction of a second and just goes and kind of runs weird. If I use a little bit of an AND gate, I'll tie these two together. So if we're above 20 kilograms and we don't have any liquid in the system, then we can turn that automation, that liquid shutoff valve to on. Okay, so inside of here, we already know how we're going to turn on the steam turbines. That's pretty simple. And because I don't really care about the power system right now, those are just going to dump into some batteries. How is this doing inside of here? 31 degrees, that's pretty good. 34 degrees. Okay, so the Weezewort's doing its thing. It should probably be up a little bit higher. What I set up over here was just Weezewort's inside of this area, just to kind of try to potentially cool that a little bit. But what you could do is you could do the same sort of thermal door system right here with like a bunch of Weezeworts or something like that. That's just continuously cooling this area. And then you open or close those couplers, those doors, in order to cool off the natural gas inside of here, or the hydrogen inside of here, and cool the natural gas generators while you're at it. Or you can just stack a bunch in there. The thing is, you don't want it to get too cold and then end up with ice. That would be bad. But otherwise, I'm not sure it's going to be a big deal. Although you might want to actually control the temperature when it goes to pump out. So now that I've got natural gas inside of here, it's going to then be radiating through these metal tiles. And the important bit here is once that temperature goes down below 300 degrees, then doors down here will open up and let the natural gas down. So I want to deconstruct these tiles and replace it with doors. Now I may want to limit how much I'm letting into this area. I might not want to have this be all doors, but we'll do at least 3. Mainly because we're going to get some heat soaking from this area into that area and that area into that area, but we know that we're cutting off the maximum temperature down here, so that's... And down here for this thermal sensor, which will be close by, will hopefully be below 125, because I don't want it to go in there and melt the stuff down. So the one problem I have right now is I don't have a feedback system here in order to say that, you know, look, I can't cool down this amount of natural gas, so I might end up with just more and more natural gas being flooded into this system. So I probably want to have an Atmos sensor somewhere down here, and then I could just easily string in another AND gate right here, just like right here. So we know both of these conditions are true, right? And what I want to say is, as long as I don't have too much pressure down here. So as long as this is below 5 kilograms or 10 kilograms, we'll start it off with 10 kilograms. That'd be a lot of natural gas inside of there. Okay, so there's a couple of liquid shutoffs that I don't have accounted for. So I'm just going to put them right inside of here. So that looks like that. And then we also have an automation wire that runs over here to this and over here to that. And then the final ingredient, obviously, is power. So we'll just put some water in there. Water. We could probably put another pump in here. Once we get up to a certain amount, we can then pump it away. I don't know. Let's see if the system works before we go and try to get too complicated with it. But I think right now, this is a simpler system, even though it is still big, than what we have going on over here with all of these sort of this madness. We also don't have any recirculating steam things. All it is a room for natural gas, and then a room to make some steam, to potentially run some steam turbines, and then preheating the natural gas, the crude oil. The last step is cooling off that natural gas a little bit more, although this might want to be a little bit lower. So we might have to space out where this gas pump is. These might have to be over there, something like that, so that the temperature that goes from here on out, I was talking about that being, what, 200 degrees? So maybe that's more like 200. That will probably be still too hot. However, if I use some thermal shift plates, I might be able to cool it down fast enough. If I do this number, I guess I need a pump up there as well. 2 of them. They should really be on the left side. Natural gas will try to find its way through here. I was just thinking about that with that mechanized airlock. Maybe that airlock, if you were to rebuild this, would actually get built into kind of this water, so that when you have your exosuit on, you could just kind of go through that as a water lock, so that polluted oxygen doesn't find its way out of this area. So I'm just going to have a thermal sensor right here. And if this is above 100 degrees Celsius, and then this pump will run and it'll recirculate some of the polluted water from here upwards. So that's above. Okay, that'll work just fine. Oh, that's what I'm doing wrong here. Hang on. So this right here, nope. That, I'm putting polluted water in there. That's what I want. All right, cool. Much better. This really doesn't do anything. You just kind of pump it away. Okay, so I want to make sure I have these doors set up on an automation line as well. You know what I'm doing here. This guy just is like that. And so long as that is below, sorry, if that goes above 110 degrees, we'll say this time, then it'll open up and cut off the transfer between the two. Oh, which means I should probably have a protection for these doors as well. So if that's true and this one is not true, then those doors can open. Like that. All right. Enough messing around. Let's get this thing up and running. Alrighty. Here we go. We're going to add... Save game. Add a little bit of natural gas to this. Make sure we switch that to that, and that. Okay, so that thing doesn't run. Wait a minute. What am I doing wrong? I don't want that to be below. Automation drives me nuts. Alright, here we go. Come on. Sweet. So I'm getting a bunch of natural gas. The only thing is this runs kind of on a slow timer right now. It's every 5 seconds or so. You can see I got a bunch of natural gas in there. Put a little polluted water in there. There we go. Make sure I got that all set up. Save game. Oh, you know what? That'll make polluted oxygen inside of there. Oh well, whatever. So this is working. It's not throwing stuff all over the place. It's just working well. So now we went above 20 kilograms right there, and I'll let some through, and we can see the temperature. So we're increasing the temperature of the polluted water, and it's still below that correct temperature, so we're not shutting these doors off yet. It's got to get there pretty soon, though. See, we got 5 kilograms of natural gas flowing in. So far, so good. I put 200 kilograms of steam of polluted water up here in 2 spots. Oh, we can see now this one's starting to close off. All right, so far, so good. The temperature that it's at down here, that's 50 degrees Celsius, so that's pretty good. I might have too much polluted water up here. Let's just cut this down. There you go. Not much. So this turned into steam. You can see all of the dirt I have in there now. And at what temperature does dirt melt? 300 degrees. Okay, sweet. So it shouldn't, shall I say, actually turn into sand. I might actually want to take this and put it at like 275 just to make sure. So this system here seems to be working pretty good. You can see the door kind of flipping to open and close a bunch of times. There we go. We added a little bit more. So it just keeps building up, and it should keep building up. You know, at the most, we might end up with 20 kilograms across this entire area up here. At that point, this couldn't flow over anymore. And since we're not doing anything crazy with the door compressors or something, we can just go ahead and speed this game up a little bit here, just to see what happens temperature-wise. So we're still waiting for this steam to heat up enough. It's got a lot of stuff to heat up because we've got all these steam turbines and whatnot up there. Well, startup is always going to be difficult. Oops, I need more crude oil. Okay, so at this point, we've put 20 kilograms of natural gas up here. And the temperature where I'm sensing it is 370 degrees. Unfortunately, that was hot enough to turn this into sand, which really made for a problem. So I've discovered my very first problem. This thermal sensor needs to move down. Oh, and the Atmos sensor also needs to be down here on the bottom as well, because guess what? Steam is heavier than polluted oxygen. So the polluted oxygen finds its way up and causes a problem. Or I could pretty much always put it over here on the right. That might work too. But matter of fact, I think I'll go ahead and do that. So heavier gases want to move to the bottom right. Look at that thing. It's having all kinds of a bad days. Above that. And above that. Oh, you know what would also help? If I plugged it into the door. There you go. Come on now. Somehow this chamber turned all to polluted oxygen. But hey, look, the rain system's working. Alright, we'll put more polluted water in there. Quite a bit more. Let's see what happens now. Hey! Alright, we're getting our first running of natural gas. So we've built up enough pressure down here to where the natural gas is starting to flow through, and we've got polluted water that is coming out the other end. And that's coming out nice and cold. Wow. So you can see that is now dribbling down, and that's cooling off the metal tiles. So as long as that is below 500 kilograms or so, this will continue to fill up. Interesting. The other option is that this polluted water would then go to a fertilizer synthesizer. However, we'd like to warm it up first, if possible. Now... once again, do I simply not have enough natural gas generators? Looks like I don't. The copy-paste machine might get a second go. This up here, may not even be worth it, even though I am using steam, or trying to use steam. Come on. I want at least to be able to get some dirt out of this thing. Maybe I just scrap the whole generator and just don't even worry about it. Just try to get it hot enough to make steam and then have it condense back down. I know it's a little annoying and we don't get as much power out of it, but yeah, you get dirt, and that's useful. Oh no, do I not have enough room? What am I gonna do with all my natural gas? Oh boy. Power, power, power. Come on now. Make these natural gas generators. You can do it. Bam! Boom! That's what I'm talking about. And then some power. Connect it all together. Don't do that. Well, okay. Guess you did. Wonder if I'm going to overload. I'm probably going to overload my heavy conductive wire. Alright. That's impressive. Hope you can figure this out, natural gas. Find a place to go. Whoa! Okay, there we go. So now these are finally keeping up with the rest of the system. So what's going on over here now? The temperature inside of here still above 300 degrees. So we're waiting for this polluted water to cool down this natural gas. That's kind of the slow spot, huh? What can we do to speed that up? What if we put that right there, huh? So now it's kind of in contact with that metal tile. That seemed to make a big difference. Wow, okay. So if that made an improvement, then let's do more. So the temperature of the oil that's coming from down here, you can see this is, wow, only 4 degrees Celsius? That's actually really quite cold, but by the time it's getting to the top of the system here, it's 195 degrees Celsius, so it's really picking up a lot of temperature there. I must have painted that in quite cold, which makes sense that it would be cooling down as much as it is. That's not as cold as I really want that crude oil to be, though. I really want it to be warmer in order to get kind of an accurate number here. So that needs to be at least 367, something like that. So that's 91 degrees. That's pretty close. That's a little bit more accurate. Looks like I had... Oh, nope. All right. This isn't a bad problem to have. I need more gas pumps. But mostly I need a better spot for them to go in because it's getting all kind of confused up in there. Automation, connect the dots, power, try not to blow up your wires, probably gonna happen. And ventilation. I really shouldn't be plugging 3 of these into the same pipe. It should only be 2, but oh well. That's what I'm doing. And I should really have this split out quite a bit better than what it is so that it divides its choices as each time it moves to the next spot instead of just doing like one entry and then having one point to another point to another point. You'd want to go to 1 to 2 and then from 2 to 4. But hopefully they'll add another like Y bridge at some point, and that, you know, we'll be able to kind of separate this out a little bit better. Don't tell me I don't have enough natural gas generators at this point. Okay, so here's... Oh, buddy. See? This is why you don't do it wrong. You do it right. So that can go that way or that way. And then it should split between the two and hopefully not get confused. No, it's definitely confused because it's got a loop. Don't do that. There we go. So these gas pipes over here, that's all feeding this system, and those 3 pumps are feeding this system. Okay, so what are the reports? Because these are the only natural gas generators that are running. These are not running up here. I cut all of this off, also including the steam. Just from the natural gas generators, I'm getting 8,000 in that last cycle, 8,300, 8,500, 6,862. Wow. That's a lot of power. And you know what? It looks like... Okay, so yes, I do have enough natural gas generators to keep up with demand. Awesome. And these things must have run at some point. Okay, so how is the system working now that it's been running? We can see over here that we keep building up more and more natural gas. This system is working great. It's kind of controlling the flow of natural gas into this chamber. This chamber here is doing a good job of trying to heat up this steam up here, which looks like it's about ready to run. Come on, baby. Putting these thermal shift plates on the metal tile seemed to make a big difference. Come on, you can get there. Oh, you see, and then it starts to flood right again, all over again. So now when this goes active, it will stay active. Oops. It'll stay active for a known amount of time. So we can say that'll be active for 60 seconds. And then I can do over here, I could do a filter gate so I don't get any false positives, right? And then use a buffer gate again to keep this active so that I can bring in more liquid. So after 30 seconds, I can start to bring more liquid into this system. And then that will run for 10 seconds, at least. I have 286 kilograms of steam in there. That's a lot. The temperature that it's exiting out over here, you can see that is 80 some degrees Celsius. So that's really good. The polluted water above that, really nice and cold at 57 degrees. And it's really not increasing in temperature. Definitely not as fast as I can replace it. The temperature inside, oh my goodness, it's freezing. It is 14 degrees at the top, but down here it's -5. Whoa, when does polluted water freeze? -20. Okay, so we're doing all right. Maybe a couple less wheeze-words. You can see temperature-wise, we're doing great over here because this volcano keeps kicking out more and more magma. Okay, so right now this system is in a lull because it's not really running. So yesterday we got 4,500 kilojoules out of it, which was quite a bit less. There's a couple 7,000s. My goodness, that one was 9. Oh, half my batteries are exploding up here. That's nice. How did this liquid shutoff valve die? Oh no, that's what, oh no. It's probably because it's sitting in a vacuum. Yeah, that's why. And it gives off a little bit of heat, maybe? Maybe not. Whatever this vacuum is, it's hot enough to, oh, the doors, the doors. That's what it is. Okay, so we're just gonna bring in some hydrogen. At a relatively cold temperature just to save everything. Go back to plumbing. What do we got? Liquid shutoff valve. We'll get that replaced. Let's just gonna go ahead and override these. So there we go now. That's pumping out some steam. And we can see that it's condensing over here. The temperature is way too hot. Oh, that's because I built up like 200 and some kilograms. Well, this seemed to work because I got more polluted water in there. And that was nice and cold. Oh, man. Too much steam. I now have clean water down here. Uh-oh. Oh, oxygen not included. You're messing up my day again. Here you go. Just whatever. You know what? It's still flowing. Oh, that's what's going on. Okay. Because I put way too much steam in here, this is converting to, this is getting too hot over here. So it's turning to steam and then I'm getting clean water out of it. So that's what's going on. I don't know if I'll ever be able to clean out that much steam. So we're gonna use the old vacuum trick a little bit here. Do a little bit of reset. There you go. Okay, so I'm gonna add one more thing here, a little hydro sensor, and then we'll try to pump some of this water away. Because right now it's just like filling up big time in there. I'll just dump it. So it is condensing some of that water down, but I don't think this is a very effective arrangement here because it doesn't build up enough water up there to really effectively cycle. So there's only like grams that get built up on the actual like steps. So that is not too good. What I want this to be is like a flat or maybe kind of like a puddle of some sort. Then I can kind of do this number right here and just build up a decent amount of polluted water there that's nice and cold. So now I can see that that amount of water is continuously going up. So that's pretty good. Let's go ahead and take a look at the reports for the last couple of days. Power generated 5,000 kilojoules right there, just off of the natural gas generators. Day before that, 7,800, 7,000, 6,000. Let's put this to 90, just in case. And I'll use some more thermal shift plates in here. And we can get rid of those. Those don't make any difference, I don't think. Oh, that's what happened. This thing over, I ran out of crude oil and my pump broke. Crap. You take your eye off of one thing and everything explodes. I need a source of crude oil. So we'll let this run to 175 and we'll see where it kind of ends up. So now that I've got more crude oil, it's moving in there. Got a bunch of hydrogen. This system should be up and running. Yeah, we can see the steam condenser now is actually working and working well. So that's good. I should get some accurate numbers here over the next few cycles. You know what? It seems to be running pretty darn good. There is one observation I would make at this point, though, and it has to do with the steam turbine. It really just doesn't spin up. It kind of is running into this under pressure situation, and it probably has to do with this condenser over here being just too far away. So if I were to redo this, you know, and just try to actually use it inside of my base at some point, I'd probably just get rid of the steam turbines. I mean, I know I like the idea of getting a little bit of power out of it, but compare what the effort you take to try to set this up and make it work compared to how many natural gas generators you're running over here, you know. So the system really isn't that complex when you really just put it into its parts. All we're doing is we're converting that crude oil here into natural gas. That natural gas is then creating steam to bring its temperature down so that it doesn't accidentally heat the crude oil to the point of creating petroleum within the pipes. We then run it across a radiator right here, preheating the crude oil, in this case from 78 degrees Celsius up to, well, 173 degrees Celsius. So we're getting 100 degrees out of that. So there's a little opportunity there to increase that temperature more, especially if we're not worrying about trying to get the temperature up high enough to run a steam turbine. So we could make the system more efficient by just getting rid of the steam turbines and trying to make that temperature about as close to the maximum temperature of crude oil as we can get. That then moves on over here, and we use the cold, polluted water that's coming from these natural gas generators, which are being chilled almost a little bit too much by wheezeworts over here. So we are using a couple of wheezeworts in order to really do the thermal cooling. However, we're taking advantage of what the wheezeworts can do to the natural gas generators because we get a lot more cooling effect out of those wheezeworts, because that is then ending up in water, and a fair amount of water, which is finding its way back in. So the nuts and bolts of it is that we're really just, you know, converting it to natural gas, and then we're cooling it down with polluted water. But in between the two extremes, so the really cold and the really hot, we're using polluted water to cool it. So natural gas, polluted water, crude oil, polluted water, pumps. Let's see what kind of reports we have. Oh my gosh, so much power. Look at this. Look at this day go. Look at this. Whoa. 7,583 kilojoules from the natural gas generators on cycle 178. The day before that, 7,300. The day before that, please tell me, 7,200, 7,455. Look at how stable this is. 7,600. Ooh, we had a really extra good day there. 7,300. Awesome, awesome, awesome. So consistent numbers for once, finally. This is one of the harder building systems that I was able to, I took on to try to build here. It is challenging. So now that I know what these numbers are, I'm going to plug these into the calculator to see just how close we've come to that original number that we thought we might be able to get out of this. Full circle. That's where we're going. Okay, so the mass of magma that we're putting out. We did start with some in there, but let's just humor me, okay? 395. We can know the temperature. Eruption period 81 per time 10513. And what that is telling me is that there should be more power in the system that I'm not getting out of it just yet. I guess I'm gonna have to build it bigger. That's saying 24,000 kilojoules. 24,000. I'm only at 7,000. But now I at least understand the formula. So, I guess it's just time to build it bigger. But that'll have to be for another time. Hopefully you guys have enjoyed this little episode here of Oxygen Not Included. Let me know down there in the comment section below if you got any other crazy builds that are going on here. You guys have been sharing a lot of these with me, but hey, this formula seems to work, and it works pretty simple. I'm sure you can make it much smaller and much more practical, and, you know, just maybe ditch the steam turbines. But I like it. That isn't too hard. And it was all thanks to your guys' comments. Absolutely awesome. If I've earned your subscription, then thank you so much for that. I'll see you again next time. Stay awesome, guys. Peace. Brothgar out. Oh, and fresh part off the printer. Check this out. Didn't even clean it up yet. Look at how clean that is. Look at that. Look at that. See, this is the one I just picked off. This was the one that I cleaned up. You can tell because it's got a little brim on it, right? See? Right there.